In this video, we will learn hyperbolic functions and see some of their identities. First, we will define hyperbolic functions. Like trigonometry, we have 6 hyperbolic functions, and later we will see how hyperbolic functions and trigonometries are related and why these functions are named hyperbolic. First hyperbolic function is sine hyperbolic or hyperbolic sine. This is written as sine h for hyperbolic. X is our variable and which is defined as e to the power x minus e to the power minus x over 2, and this is pronounced as sinh. This is hyperbolic sine. Next, hyperbolic cosine, cos h, and this is defined as e to the power x plus e to the power minus x over 2. Next, 4 hyperbolic functions are defined in similar fashion as we define regular trigonometry functions. Next, we have hyperbolic tangent, which is defined as sine hyperbolic over hyperbolic cosine, and this one divided by this one, denominators are same, 2 gets cancelled, and this is e to the power x minus e to the power minus x over e to the power x plus e to the power minus x, and this is hyperbolic tangent. Next, we have hyperbolic cosecant, cosec hx, which is 1 over hyperbolic sine, and this is reciprocal of this one, so we have 2 over e to the power x e to the power minus x. Similarly, we have hyperbolic secant, which is 1 over hyperbolic cosine, and this is 2 over e to the power x plus e to the power minus x. Last, we have hyperbolic cotangent, reciprocal of tangent, and this is 1 over hyperbolic tangent, and this is e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. So these are 6 hyperbolic functions. Next, we will evaluate some of the values of hyperbolic functions. Suppose it is given that evaluate sinh 0. What do we have? Hyperbolic sine 0 equals to e to the power 0 minus e to the power minus 0 whole divided by 2. And what is e to the power 0? E to the power 0 is 1, and this is also e to the minus 0 is minus 0, 0, e to the power 0, 1. So this is 1 minus 1 over 2, which is 0. Similarly, you can evaluate the values of hyperbolic functions. Next, we shall see some of hyperbolic identities. Now we will see how hyperbolic functions are related to each other. First, see what is the sum of hyperbolic sine plus hyperbolic cosine, and what is our hyperbolic sine? This is e to the power x minus e to the power minus x over 2, and hyperbolic cosine is e to the power x plus e to the power minus x over 2. Denominators are same, so this is e to the power x minus e to the power minus x plus e to the power x plus e to the power minus x. E to the power minus x gets cancelled, plus minus, so we have 2 e to the power x by 2, which is e to the power x. Similarly, you can show that hyperbolic cosine minus hyperbolic sine is e to the power minus x. Third, let us see what is hyperbolic cosine square x minus hyperbolic sine square x. See, here we can use the identity a square minus b square plus b times a plus b. And what is a here? A is hyperbolic cosine and b is hyperbolic sine. So we have a plus b, which is hyperbolic cosine plus hyperbolic sine times a minus b hyperbolic cosine minus hyperbolic sine. So we have got this one is e to the power x times this is e to the power minus x, which is e to the power x minus x e to the power 0, which is 1. So hyperbolic cosine square minus hyperbolic sine square is 1. You can get some more identities using this identity, that is hyperbolic cosine square minus hyperbolic sine square is 1. Suppose let us divide hyperbolic cosine in both sides. So in left, what is our identity? This is our identity. Let us divide cosine hyperbolic square, and here also hyperbolic cosine square. Left side, divide this one with this one and this one. So here you have 1 minus this is hyperbolic tangent square, which is same as this is secant hyperbolic. So till now we have the identities 1 minus hyperbolic tangent square is secant hyperbolic square. Also we have this one, this is equals to 1, and sum of hyperbolic sine and cosine is e to the power x, and cosine hyperbolic minus hyperbolic sine is e to the power minus x. So till now we have these identities. Similarly, you can also divide hyperbolic sine square to get hyperbolic cotangent minus 1 is equals to hyperbolic cosecant square. You can cancel 1 2, so denominator we have 2, and in numerator we have a minus b, a plus b, which is a square minus b square, and what is a square? E to the power x square, which is e to the power 2x, and we have e to the power minus x whole square, which is e to the power minus 2x. See, LHS is same as RHS, so we have established this identity. Similarly, we have many identities in hyperbolic functions, and you can verify them using this method, find LHS and RHS and make them equal. And you can see that there is some relation between hyperbolic identities, hyperbolic function identity, and trigonometric identities. In trigonometry, we have sin 2x as 2 sin x into cos x, and cos square x plus sin square x is 1. But here we have hyperbolic cosine square minus hyperbolic sine square as 1. Similarly, we also have sin hyperbolic x plus y as hyperbolic sine x, hyperbolic cosine y plus cosine hyperbolic x times sine hyperbolic y, and this identity looks similar to the trigonometry sin x plus y. So there is a relation between hyperbolic identities and trigonometric identities. There is a rule called Osborn's rule, which gives a idea to convert one trigonometric formula to hyperbolic formula. Suppose you have trig formula, then you want to convert it to hyperbolic formula. And what rule you have to apply? You have to convert sine to hyperbolic sine and cos to hyperbolic cosine, except you have to make note of this one. You have to be little bit careful when there is product of two sine. When you have sine times sine, you have to make the change of sign. If this is positive, then you will convert it to hyperbolic since, but positive sign, negative to positive. And if there is positive, then it will be negative sin h. Let us apply this one. suppose in trigonometry, in trig, we have hyperbolic cosine x plus y is cos x times cos y minus sin x sin y. We want to convert it to hyperbolic, so cosine will be cosine hyperbolic x plus y, cosine this one cosine hyperbolic, so sine will be sine hyperbolic, and this is sine hyperbolic y. But we have two sine, product of two sines, so we have to make the change of this sign. This will be positive. So this is our hyperbolic identity. Also, you have seen that 1 minus hyperbolic tangent square, also you have seen that this one is secant hyperbolic square x. So now you may ask why in trigonometry we have 1 plus tan square x is sec square x, but in hyperbolic we have 1 minus hyperbolic tan square x equals to sec hyperbolic square x. Why this negative sign? Because here what happens, hyperbolic tangent contains sine, and you have two tans multiplied, so two sines there, therefore this sign changes there. We have 1 plus sin square x by cos square x equals to sec square x. So for this product, when you convert to hyperbolic, you will get 1 minus secant. So this rule is useful, but to verify any identity you have to apply some method, or you will use first find LHS then RHS and show them they are equal. Next I will give you some exercises where you will verify some of the identities. These are few exercises for you. You have to verify these identities. Use Osborne's rule just to remember the identity, but to verify the identities, to prove, use the procedures. In the next video we will see some of the equations involving hyperbolic functions, and then we'll go to range, domain, graphs and calculus. Thank you.